Hey guys, I'm Alex, and today what I'm going to do is I'm going to teach you guys how to solve this problem right here. How many 5-digit numbers are non-increasing? Now, whenever I encounter problems like these, a little bit harder, something that I like to do is turn it into something that I personally know how to do. And at first glance, when you see this problem, you might not know what to do. And what I would do in this situation is I would just, experiment. And that's something I recommend you guys do as well. So let's think about this. How many 5-digit numbers are non-increasing? Well, what's an example of a non-increasing 5-digit number? Well, I guess something like 5, 4, 3, 2, 1 would work. That's a 5-digit number that's non-increasing. What are some other numbers you guys think? I guess 8, 7, 7, 6, 4. That's also a 5-digit number that also happens to be non-increasing. Let's think. What else counts? What about 1, 0, 0, 0, 0? This also happens to be a 5-digit number that is also non-increasing. Well, I'm realizing something that I'm writing these down. Well, really, I'm realizing two things. First, that it's going to take way too long to write down all the non-increasing 5-digit numbers. But it wasn't a complete waste of time, which brings us to number 2. All of these non-increasing 5-digit numbers have distinct combinations of 5 numbers. Well, you guys might be like, oh, that's so obvious. What is this guy on about? But just think about it for a second. What does that really mean? If we take the numbers 5, 4, 3, 2, and 1, there's only really one non-increasing 5-digit number that we can create out of it. And it's as follows, 5, 4, 3, 2, 1. No other arrangement of those 5 numbers work. Like, for example, 4, 3, 5, 2, 1 doesn't work because 5 is bigger than 4 and 3. And that's not just an exclusive property to 5, 4, 3, 2, 1 as well. Let's think about 8, 7, 7, 6, 4. Well, if you take the 5 numbers 8, 7, another 7, 6, and 4, this is really the only non-increasing 5-digit number that you can create out of those numbers. And same thing for 4 zeros and 1, 1. You can only arrange them in the order 1, 0, 0, 0, 0. And would you look at that? Just by experimenting, we've now switched this problem into something that's just a little bit easier to solve. So we've turned the problem, how many 5-digit numbers are non-increasing, into the problem, how many ways are there to have distinct combination of five numbers that don't necessarily have to be different. Now, you might be thinking, oh, well, that's so easy. Just think about it like this. Well, the first digit can be between 1 and 9, so there's 9 options there, right? So there's 9 options for the first digit, and then all the other digits can be between 0 and 9. So now you have 10 for the next, and then 10 for the next as well, and then 10 for the next, and then finally 10 more for the final digit. Problem solved, right? Well, not quite. You'll notice that you do quite a bit of overcounting using this method. Because just think about something like this. Using this method, you count something like 5, 4, 3, 2, 1, but you also count something like 1, 2, 3, 4, 5. In fact, you also count something like 3, 2, 1, 5, 4. And whereas in the system that we're trying to find, all of these would represent the same combination of 5 numbers. What you've just done is found a method that represents these as all distinct. Now, you might be thinking, oh, distinct? I know how to do distinct. Well, let's just think about it like this. If the first digit has to be between 0 and 9, so let's just write that down real quick, then the next digit, well, it can't be the same as the first digit. And now it can go between 0 and 9. And so let's think about that for a second. So you have 0 and 9, that's 10 digits. You subtract 1 for the first digit, and now you get 9 more. And then you continue doing that. You subtract 1 again, because you can't use this digit. You get 8, and then you get 7, and then you get 6. Look at that. We just solved the problem. Well, once again, not quite. What you've done here is actually found how many ways there are to find combinations of distinct numbers rather than distinct combinations. So the cases that you've actually ruled out here are examples like 1, 0, 0, 0, 0, because these numbers are all the same, and they don't work under what you've just come up with. But unfortunately, we're looking for numbers like that. So that doesn't work either. So you might be wondering, look at this guy, bro. He just wasted all this time telling me solutions that don't work. Why don't you tell me a solution that does work? And I'm going to do exactly that. So the way you can imagine this is you imagine all the numbers 0 to 9 as individual distinct numbers that you can give a ticket to get onto your team of 5 numbers. So let's just write them out here. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, and finally 9. And you have 5 spots on your team because you need a combination of 5 numbers. So you have 5 tickets to give out. And let's just split these guys up a little bit so they each have their individual container for you to give their tickets. So 9 gets everything on the right of this bar, and 0 gets everything on the left of this bar. So let's start distributing the tickets. Let's say we don't really like 0 that much. Get this 0 guy out of here. So let's just skip to the next guy. Let's go to 1. Let's say you like 1. Let's give 1 a little bit of a ticket. Let's give 1 ticket. 2, you're not a big fan of 2. To be honest, me neither. So let's skip right to 3 and give 3 2 tickets. Maybe we're big fans. Let's skip 4, because who really likes 4 in the first place? Let's skip 5, and 6 is my favorite number, so let's give 6 2 tickets. And then we skip all the way to the end. So what we've done here is that by giving tickets to these numbers, we've actually just chosen our distinct combination of 5 numbers. The numbers that we've chosen are 1, 2 3s, and 2 6s. And lo and behold, what we've done is that we've just created a group of numbers that can be rearranged into a non-increasing 5-digit number. In this case, 6, 6, 3, 3, and 1. But how many ways are there exactly to do what I just did? Well, here's a way of thinking about it. If you think about it holistically, there were a total of 14 moves that I did to get from here to the end. Well, in order to get from 0 to 9, I had to skip 9 times to get to the next number. I had to go from 0 to 1, 1 to 2, 2 to 3, 3 to 4, and so on and so forth. But something else that I also had to do is I had to place down my tickets. And I had 5 tickets to place down. So the total amount of moves that I had to do to get from 0 to 9 and give out all my tickets, if you think about it, there were really 14 moves that I just did there. 9 plus 5. And if we want to find out how many ways there are to give out these 5 tickets, well, out of those 14 moves, I just have to choose 5 places where I give a ticket. And what we've left with is actually just 14 choose 5. Which is the exact same thing, if you think about it logically, as choosing the places that I want to actually switch numbers, which there are 9 of. And look how convenient that is. 14 choose 5 is actually the exact same thing as 14 choose 9. So let's just think about why this works for a second. You might be thinking, oh, okay, let's choose 5 places. Let's say for the first 4 places, I want to put them all on 0, and then I want to switch. I want to put 1 on 1, and then all my other ones are going to be switches. Now, that is a possible solution, but what number do you get? So let's give 0 4 tickets. Let's give 1 ticket, and what you end up with is actually this number right here. So now you might realize something. Wait a second. We want 5-digit numbers. If we have a whole bunch of zeros in there, won't that mess up the number at the end? Won't that make it like a 4-digit number or a 3-digit number? Well, kind of, but not quite. Think about it like this. If only one of the numbers that you choose isn't 0, or more than 1, then that number has to come before the 0 numbers because it's non-increasing. So that means that as long as you have just at least one non-zero number within your combination, it's going to be 5 digits. But you're a pretty smart cookie over there. You actually figure something out. Because if you choose have all your numbers chosen be 0, which is a possibility in the example that we just laid out, then that's not a 5-digit number. So you've ended up finding a case that doesn't work. What a smart guy you are. So 14 choose 5 ends up being 2022. And if you're wondering how I got that, well, let's just say I'm your math teacher for a reason. But you're right about having one extra solution that we found. So we take our 2022, we subtract the case where all the numbers are 0, and finally, what do we end up with? 2021. What an innocuous year. Thank you so much for listening.